start sharing my screen. Okay. Can someone help me what we have discussed yesterday? Okay. So we discussed the decorators. So decorators are nothing but what? Higher order functions only, right? So it is taking the function as a function parameter, right? As simple as that. And then we started looking into the oops, where we were looking at what is a class, right? And what is the object, what we will derive from your class. Okay. So this is what we have discussed. In the oops, okay, we'll discuss further on the oops. What are the different topics? In the decorator, one small thing yesterday I was experimenting. Okay, let me show you. Okay, so if you look at this one, I have added this code, how to manage your keyword args, right? So here, while passing these particular parameters to your function, right? So this is how you can pass your parameters, right? So here, if you look at this, here I'm passing this particular parameter. One is your normal args and keyword args. This is how you are passing, so that you can take both keyword args as well as the normal args, right? I have added this particular example also. So this has been attached in your Google Classroom. Please refer to this one. Okay, how to use both args and keyword args also. Okay, so that your function can be as generic as possible, so that you can apply the decorator on any sort of functions. Okay, one more small correction is, so you can add more than one decorator also. Okay, so let's say now here I've added security. If at all I want to add logging, okay, for this particular function, I can write it in a one function where it will log also. Okay, but here you need to define like this rather than comma separated or something. You can do a few more things over here. Okay, like this you can add multiple decorators also in the normal function. Okay, so that is one update. And there is one more thing. Somebody asked yesterday, what is if I tell I want to do the post logic? Let's say this is a pre-logic, right? Whenever you are running this particular function, so before this one it is calling. But actually, if you look at deep into this particular decorator, so whatever you are running in this particular function, right? Rather than working on this particular only logic, along with this logic, you are trying to execute this particular logic before calling your function, right? This is the additional logic you have attached for your function. Now, after this function, if at all you want to update these return values, okay, you can take into this particular parameter, okay, whatever it is returning, you can take into this and you can update those values. For example, you are returning this particular, maybe here I will return okay, if at all you are returning this particular values, that will come into your result. Okay, so that result you can operate on. Okay, you can update, if at all you want to update these results, you can update this particular result post your function also. You can update whatever you want. One logic is before the calling your function, you are updating your parameters and sending it to your function, and function will execute whatever logic it has, right? And then after function execution, if at all you want to call certain logic, you can execute that particular logic post that particular function call also. Okay, so that it can do both pre function call and then post function call also you can update. Okay, if at all you want to run some logic. So these are the two small enhancements on top of what we have discussed on the Dockers. Okay, so now going back to the OOPS concept. Okay, yesterday we have seen the what is a class and object. So we are trying to group both data as well as the functions in a one single unit, which is nothing but your class, right? And then if at all you want to use the particular blueprint of your class, you would be creating an object. And we have seen the syntax in the Python. Okay, so now let me open that. Oh, did I close? Okay, let me reopen. Okay, if we add multiple decorators, it will execute from the top, bottom to top. Okay, first it will execute the first decorator, and then it will go top, next and next and next. Okay, the same function will pass it to this first. Let's say first you want to add security and then you want to add logging, right? So first it will execute this for add security and then it will pass it to log function also. This particular decorator will get executed next time. Okay. Okay. Now let's come back to OOPS. So this is what we were discussing. Once you create your own class, within the class you have defined your own functions, right? And then if you have two more parameters, this is where your class is, right? So just the syntax is class, this is a keyword, and your class name, right? So within this particular class and class name, you will be defining your function and the attributes. So if at all you want to create the actual object of this, here I am creating the actual object. Within this one, if at all I want to call those functions, I can call by using my object, right? So this is what you will be doing for your class and object. The syntax is very simple, right? So in other programming language, you might create like this, right? Let's say in other programming languages, you say class name, then the reference, right? And then you will use new database, right? So that time it will create an object and assign it to this particular object of type, the data type of your database, right? So that means whatever list, set, dictionary, or any type, right? Those are like a classes only internally. But here I am creating my custom type. So class is my custom type where I would be creating different functions. If you think about a list, okay, whenever I'm creating a list, right, I am simply calling list dot append, right? That means that particular list is also created like a default object inside your Python. But here I am trying to create my custom type where I will be defining my data and I will be defining my functions. This is a custom type. Okay. So now in Python, it doesn't force you to assign this to a same type, right? Because in Python, we are not writing int x or string some other variable name, right? So we are not defining. Similarly, it won't restrict you to assign an object to this particular type. Okay, I need not to write what is this particular variable whenever I'm creating an object. Okay, so if you know other programming language, right, sometimes what they do, they create an object of child to a parent reference, and there are a lot many confusions happen with that programming language. But in Python, you never have that kind of a confusion. Okay, you can assign any class object into this. Anyway, we'll come back to that. We need to understand a few more concepts like child class, what is child class, and all of that. Okay, so let's look at the next topic of, let's say now I have created a class. So why I need to create this particular class in first place, right? As I told you, you should have a modularity and then scalability and reusability, right? So let's look at few more. The concept is called inheritance. Okay, so what is this inheritance does? Just like our regular life, right? Let's say if your father has a property, obviously child will inherit all those properties, right? Whether he write a will or not, you are the legal heir to get the property, right? Similarly, let's say I'll write a parent class. Okay, my class name is parent. I need to use colon. Sorry, I need to use first this colon. Uh, Now I need not to use this one, right? I will be using this. Okay, so now I will be defining my function definition property. Maybe okay, function name, and then I would say uh, okay, and then let's take one more. Okay, so now I have defined my parent class. Okay, the parent has one building and one land. Okay, so now if at all I wanted to capture that same properties by your child, right? What I need to do? Class child class name. Now to inherit this particular parent to your child, right? So I just need to say, and then automatically these properties will come. Now definition. This child has earned that particular property. Okay, so this is his property, and then the land is also probably he didn't earn the land. Okay, he has an and only building too. Okay, that means the child has actually three properties automatically, right? Let me create an object now. Okay, it has done. Now let's create a object child 1 equal to child object. Okay, and child 2 also. Now if at all you wanted to call child 1 dot building 1, right? And then child 2 dot land. Okay, so both the childs will get the property of your parent. Okay, let me where is the okay. So for your inheritance, this is what we were telling, right? So your parent class and your child class. For your child class, you are taking your parent as your inheritance. So you need to tell for your child class, you need to take this particular parent class, right? Now I am trying to call your child 1 and child 2. Both will inherit the same functions, right? Because both are child classes of your parent. Now if I run this, okay, okay, understood. So now I'll tell you one small thing to take. I'll tell about this self. Don't worry. Okay, we'll come back to that particular self. Okay, for now I have defined this particular function. So let's say I inherited this particular 2 from your you have created child 1 and child 2, then you are trying to call this particular functions, right? So that means the parent it has. Let's say now if you want to access child, obviously you will have a child property because it is earned by the child 1 only, right? So building 2, right? But child 2, okay, now, yeah, both will have their own building as well as from the parent, whatever properties they have got it. But in real time, why this is useful, right? So when this is useful is one is this kind of a behavior, but this is very generic behavior to make you understand whether the parent-child relationship, how it works. But in a real time, I wanted to create a base functionality which will be applicable for all your subsequent functions. For example, what I will do, let's take an example of car now. Okay, let's say what you will do, you will design only one engine, let's say 1.5 liter engine, right? They will use the same engine for your Karen's car. Let's take Kia. They will use it for Karen's. They'll use it for Seltos. Even the Hyundai and Kia are the same sister and parent companies, right? So even Hyundai also use the same engine, 1.5 liter engine. Even in Hyundai, Creta, though Creta and Seltos looks like competitors, but both are from the same company. The parent company is same for both. Okay, so they use the same engine across all their cars, right? That time what they will do, they will design one car engine as a base class. Okay, the same engine would go to all your subsequent cars, right? And then you will expand the functionality of your car, not the engine. Let's say in the Seltos they may add few more, they will give a better width, better color, or some other features they will add, but the engine is same, right? So like that, if at all you want to design a base functionality, core functionality, that you will add as part of your base class, rather than repeating the same logic across all other classes, I will try to inherit. So that is why I would be able to get the reusability component, right? Let me show you that particular example. Let's say I have defined a class. Okay, I have defined my class. In this one, define. Okay. Okay. So now you have defined your base class for any car, right? I would be using same functionalities, right? So my base functionality I have defined in my parent class, right? Now, if at all I want to design a car, car one, okay, I will inherit this particular engine to my car, okay, and then you will be entering, you will be writing definition of, let's say, ventilated seat. This is specific to this particular car only, right? Let's say you take a different car, maybe rather than car, you will say Seltos. Okay, here you will uh, use the same engine. Okay, now you will be using, so for example, it has a different feature called airbags where Seltos might not have. Okay, so you have defined their own functionality, but your core engine, the base functionality, whatever you want to define, so that will be coming as part of your engine, which is inherited to both Seltos and Creta, right? So this is why you are using this particular inheritance. The concept is called inheritance. Inheritance. You are inheriting the properties of your parent class to your child class, or you can say this is a base class and these are the implementation classes. Okay, so now this is called the inheritance, right? You are inheriting the properties of your parent class to your child class, and this is how you would be using. Now if I want to create my object, what I will be doing, I'll run this one and then I'll simply create Seltos. Okay, so htx model equal to Seltos object I have created. Okay, so I can accelerate, I can brake, and I have my ventilated seat also, right? Now, if you look at this particular next one, I can create a same Seltos object, STO, different version, right? But it use the same class as a Seltos. Okay, and I can use the similar functions for my different versions also, right? So from the Seltos only, I'm creating multiple variations. Next, for your Hyundai, we'll use in the Creta, right? Let's say in the Creta petrol. Okay, you can create, right? I can create multiple variations from my Creta. Okay, did I create Creata? Okay, Creta. Okay, now if you can look at this, you can print. So you are able to use the same engine functionality in all other objects, but they have their own functions as well. Okay. Srinivas, if your voice is breaking, just check once. Because as we have a lot many people in the Zoom meeting, it is the voice quality would change from sometimes it may be deteriorating. Wait for some time or you try to rejoin, just so that it will be good. Okay, this is how you have the inheritance, right? So very simple and straightforward. And one more thing, in the inheritance, there are multiple inheritances defined in a Python. Okay, the first and foremost is single inheritance. That is nothing but whatever we have seen, that is your single inheritance. Okay, directly you are trying to inherit one parent class to your child class, right? But sometimes you want to inherit more than one functionality into your child class. Okay, if you want to have a two parent in your child class, in that case what you will be doing, you could use your multiple inheritance. Okay, so what is multiple inheritance is a child class inherits from more than one parent class. Okay, how it can be done? Let's say you don't take only from your father, right? You want to take your mother properties also. Okay, so that time what you will do, you will define one parent class. This is a parent 2 class. Okay, and then both you can inherit from into your child class, right? See here, father and mother both will come. That means both the classes properties will come to your child class. Okay, now let me class keyword and my parent class name, right? So let's take a banking example. I have account 1, probably I will say rather than account 1, savings as a type. Okay, here I will use no, use balance. Okay, let's say I have a current account also, savings account, current account, right? Now I am creating a one actual account, right? So there I will use class account, and then I will inherit both savings functionality as well as current account functionality, okay, into my account, right? Now I need whatever functionalities you have for a savings, you will be defining in this class. Whatever are the functionalities for your current, you will be defining over here. Then you will be attaching to your account, right? Let's say you have a credit card. What you can do, you can say define class credit card. All the credit card functionalities you can define over here. For now, I am not writing any. Okay, I want to decide later. That's why I use pass keyword. Right now, I have inherited both savings and credit, current and credit also. Right, like this, I can get all the functionalities. Now, I will use in this particular class, I will use a function withdraw. Okay, within the withdraw, Okay, if at all I want to use the functions of the savings, I can use the functionality of savings also. Let's say I want to use a, okay, we'll discuss that one. I need to discuss one small topic to use your parent class functions into your child class function. We'll discuss that one. Okay, directly you can, for now you can see, you can, if at all you want to use, you can use this particular functionality. Let's say I will run this. Okay, now if at all I want to see account one. Okay, so I've created an account from by using, from account you can use a use balance and use a withdraw also. So now you have, as you have a same use balance from coming from a multiple parents, right? So there is a one, that is why one, this one what you call topic I want to discuss before using. For now I'll create a different function only. Okay, uh, savings outlook, what functionalities would be there? Savings account, save money. Okay, we'll come across if there are same functions, how it will, how we can differentiate same functions across two different parents, we'll see. Okay, okay, self is not there. Okay, now I am able to use this way. Okay, now let's understand this self, because this is self becomes very important, right? Because it is throwing exception. Before discussing other inheritance types, first let's discuss this self and then we'll come back to these inheritances, right? So yeah. Generally, what is this self here, right? So it need not to be only self, it can be any name. Okay, it can be, let's say, this or me, whatever, right? In some places they will use some name as this, some name as a me, or you can give your name also. That's not a point, right? But here, what exactly I am trying to pass within the each function of my class, that is more important, right? Either you can mark it as this or me or some programming language, write it as a self. It is just a convention. It is not mandatory to give a specific name, right? But what this particular name or the particular variable is doing, let's understand that one. So here, what exactly it will do is, if at all you want to write a function within your class, you are writing this particular function to be called by using an object, or you wanted to call that particular function by using a class name. That is what differentiates. Okay, so now let me write one more function saying, where is this? Yeah, here I will say other than withdraw, check balance. Balance. Okay, now I am not writing any self here. Okay, but now this function I cannot call by using an object of this particular function, but I can call this particular function by simply using my class name. Okay, account dot check balance. Okay, I didn't run this first. Okay, now let me run. See, now it is running. But if I run with same check balance with your object, okay, let's say this is your object of your check balance, right? Let me use this particular one dot check balance. It will throw you an exception saying account check balance takes zero positional arguments, but one is given. What it means is whenever you are calling a function by using the object of the class, automatically the object will be passed as a parameter to your function. Okay. Again, I am repeating here carefully. Whenever I am calling a function of my class by using an object, my object of the class will automatically passed as a parameter to this particular function. That is why whatever function you wanted to call by using your object, it must take a one parameter called self, this or me, whatever it is. Okay, that means you are passing the same class object as a parameter to this particular function. Okay, why we are passing like this? Because if at all you have defined any data inside your class, right, to refer those data inside your function, you are trying to pass that way. Okay, let me show you clearly where it will make sense. Okay, for this one, let me create a small example class student. Okay, I have this particular student. Student has a ID name. Okay, let's define a name. Name. Okay, for now I am assigning a 0. Okay, so now I am defining a function set values self. Okay, now I'm passing. Okay, enter my name, this one. Okay, see, I have defined this particular student object, sorry, student class. I've given two properties of a name and ID. Okay, so now I want to create an object of this particular student, right? Let's say the student name is Prithvi. Okay, and then I would be creating an object of this particular student. Okay, and the other one would be, let's say, Rakesh. Okay, I will be creating a one more student. Okay, now whenever you are creating an object, sorry, object of your class, right, and whenever you are calling by using this particular Prithvi or Rakesh, right, first it will call this particular set values, but this particular Prithvi, right, maybe I would say I would pass name from ID so that I need not to enter from here. I would say name and ID. Okay, so this makes more sense. Let me pass name here as a Prithvi and ID as 123. Okay, and then here I would pass as a Rakesh and pass as a basics. Okay, let's say rather than calling this as Prithvi, I would say student 1 and student 2. Okay, now I have printed. Okay, so if you now I have defined my class, I have taken this as a self, but here I am not passing any parameter. If you understand here, I am passing only two parameters. Ideally, what should it should throw? It should throw an exception saying, Baba, you are passing only 2, but I expect 3, right? But here, as we discussed the particular object of the particular class, if you call any function, by default, your object has passed as a first parameter of your function. By default. Okay. Why we are passing this one? Because I need to set the properties of my object in my class, right? That is why whenever I say self.name, this particular self.name is only for your student object only. Okay, whatever property you set to yourself, that belongs to that particular object only. That is why Prithvi and this particular ID will be only assigned for the student. But how do you differentiate between this object value and this object value? There should be some differentiator, right? So that is why I will define it as a self, and then I would be using the particular property. Now I don't want to keep that as a specific to my object, but I want to keep that at a what you call at a class level, right? I need not to specifically put into yourself. Okay. So that is why if at all you want to have any properties specifically assigned to that particular class or object, that is where I will be defining this particular self, and then that self would be taken a property. Okay. So that that belongs to, though it you have defined these properties at the class level, but these are specific to your object. So your student dot name, whenever you call, it will tell you your name is Prithvi. Whenever you change it to Rakesh, it will change it to Rakesh itself, right? Okay, let me run this student. Whenever you run this, it is calling the respective object's name, right? So the self will act as a attaching to your object rather than a class level. And then whenever you use this particular object, that object will be passed as a first parameter of your function. That is why any instance function, okay, this is called instance function. If you don't have instance function, let's say, let me write a class level function. Definition, get value, but get value doesn't get you the self. Okay, that time it cannot access. It can only access by the class, right? It is not related to your student one only or student two only. It is across the class, right? Method or function, whatever it is, right? So now I can't call this particular thing with your student. It is not a property of your object. It is a property of a class. Okay, now I can directly call by using my class name. Okay, so this is what it will be used. Got it? So now in this case, you cannot use this particular function because I am not accepting a parameter of self. Whenever you don't pass a self, that time what you will do, it will throw an exception. What is telling? Okay, let me rerun this code. After adding get values, I didn't run this code. Now let me run this. See, this is a class level function. Now this is why the self is important, because any function to be called by using your object, it must have a first parameter as a self, because the function, whenever you are calling with the object itself is a passed as a first parameter of your function. If you want to define that as at your class level, by your class name only, if you want to call that one, that time you need not to mention this as a self. It will automatically consider that as a class method versus this instance method. So this is how you can see the difference between your class functions and the instance level functions. Okay, this is the self parameter. Okay, and this is not a keyword, this is a convention. Here you can write it as a this, because you are telling that I am the same object of your class, right? Some programming language they may say it as a me, whatever name, even I can keep my name also. But the first parameter will always be the self. the same class object will be passed as a parameter to that particular function. Okay, this is a self, or this, some programming language use this. Now let's come back to inheritance. Okay, so we discussed multiple inheritance, right? And then here one interesting thing, in other programming language it will give a lot of problem, but in this I don't have a problem. Let me show you. Okay, now I have, in the earlier example, I have taken two parent classes, right? One is savings account, other one is your current account, and then the credit card also. Sorry, this credit card. Okay, so this credit card also, right? So now I have inherited these three classes. In other programming language, what was the problem was, I can create my parent. Let's say if you have a savings, and then they used to create like a reference for this. Save the object name. Okay, new child class. Okay, they used to create like this. That time what they will say, my child class, my your parent can hold my parent object also. In the Java or .NET programming languages, this kind of a problem is there. Even though you are creating an object of your child class, you can assign it to one of the parent class reference. So there will be like a which function get called, whether this particular function get called or not. So many interview questions would be there, right? In Python, they have made it simple. You can't assign any object to your parent class or child class. That is nothing is there. There is no reference kind of thing. Whatever object you create, the same ob class object will be stored here. Okay, if at all you want to create your parent class object, you have to create an object of parent class only. You can't create an object of child and assign it to a reference of your parent. No, that kind of a complexities Python never allow you. You can simply assign your class object to your class reference only. You can't assign child class object to your parent class reference. That is not there. That interview questions will not trouble you in Python. You can simply say that you cannot do here. One class object you cannot put into a another class reference. Okay, that questions are not there in Python. Happy, right? Lot many questions, lot many confusion is gone. Simple, straightforward. You create object, that object holds that particular class only. Okay, I hope other programming fellows might know what I mean, what is the pain they used to face in interviews, right? So in Python, that problems are all solved. I don't worry about it. Now, if you look at this multi uh, inheritance, right? You have a hierarchical inheritance also. What is meant by hierarchical inheritance? Let's say you have a grandfather. Okay, you have a grandfather. Grandfather has a properties, and your father has inherited the particular properties. Now you have now you have, so you will be inheriting from your father. Now you will be inheriting from your grandfather also. It is not girlfriend. This is grandfather. Okay, so you have your grandfather property also, where you will be inheriting both father and grandfather properties also. Okay, that is nothing but your hierarchical inheritance. Okay, so now, okay, so sorry, that is a multi-level, not a hierarchical. It is my bad. So multi-level is like that. Your parent will inherit your grandparent, and then child will inherit your parent. So that obviously your child will have all the previous grandparent and parent object. That is called multi-level. It is my bad. It is not hierarchical. Hierarchical is a little different. So hierarchical, what it does. So here multiple child classes will inherit the same parent class. That is called a hierarchy. Let's say your sister and you, will inherit your parents' property, right? So that is what is called the hierarchical inheritance. Okay. So here I have taken the animal. Your dog is also one animal and your cat is also one animal, right? So you will be inheriting your property. One is a property of an animal, any property of an animal, that should be same for your dog and cat, right? But dog will have its own properties and cat will have its own property. That will be defining your child class. So that's exactly what we have seen in our previous example. Without knowing that, we have implemented this particular hierarchical, right? So two childs we have. Yeah, here we have created Celtos, we have created Creta, which inherited the engine, right? That means two different child classes inherited the same parent. This is called a hierarchy. The hierarchy at a different child, you have inherited the same parent. If it is a multi-level, then your grandfather and father has inherited the child. Okay, you need not to know specifically that particular inheritance type, but without knowing also, we will be doing all these inheritance, right? So maybe in the interview, they may ask whether it support multi-level or not, hierarchical or not, but it will support hierarchical and it will support multi-level inheritance also, and multiple inheritance also we have seen. Okay. So with this one, what you need to understand is to get your reusability. That means I have defined some functionality. I need not to rewrite the entire functionality, like functions in my other class, right? I simply need to inherit in my child class so that all the properties, all the functions of my previous class would come into my child class, so that I need not to rewrite. I am reusing the logic, right? At the same time, I am modularizing my code also. Modularizing is what? Rather than writing everything is in one single class, I am splitting my functionalities into core functionalities in one class, and then the core functionalities will be coming into my different child functionalities. Okay, so I have achieved both modularity and then the your reusability component, right? By using this particular inheritance concept. Okay. In this inheritance, there is one more called hybrid. Hybrid is nothing but what? You wanted to use multiple inheritance, right? And then you wanted to do multiple, let's say you have animal, right? And you want to take a mammal where mammal has been, animal has come as a parent to your mammal. Okay. At the same time, I am creating this particular bat, but bat will take one more class as well as this particular mammal also. Okay, so here I am taking a multi-level, right? Mammal is a multi-level for me for the bat. The bird is directly I am taking a single inheritance into my class. Okay, so that it is simple, right? You wanted to use different properties of different class. You inherit whatever way you want. As simple as that. They are trying to confuse people with multiple names and multiple functionality, but underlying concept is same. Underlying concept is what? If I use different, if I have different functions in my different classes, how could I reuse those functions? Okay, in Python, it will help, it will not restrict you to do any of multi-level or hierarchical or multiple. It will allow all type of inheritance in Python. In a programming language like Java or .NET, it might restrict, because there you have a problem of storing the child class object into parent class reference. That is why it was restricting certain hierarchy, certain inheritances. But in Python, there is no restriction because you don't have those complexities. Okay, let me explain hybrid. Okay, let me explain hierarchy first, then I'll come to hybrid one more time. People are asking to explain hierarchical. Okay, hierarchical is simple, right? So you have a grandparent. Grandparent properties has come to your parent. Let's say your father has received your properties from grandparent. Now, whenever you inherit in the child, if you inherit your parent, Obviously, parent has already the grandparent, right? If you look at this, your parent class has both this function and this function. Maybe let me write. Let's say grandfather has a building one, okay? And your parent has inherited your grandfather, okay? Now he has created building two. What it means? It means that your parent has both building one and building two because he inherited the grandparent, right? Grandfather or his father. For you, it is a grandfather, but for him, he is a parent, right? So now you are creating a one more child where you need not to inherit both grandfather and parent again, right? Because your parent already got your grandfather property. Just I will inherit my parent so that you will get building one, building two, and then if you invest in land, you will get a land also. I need not to again inherit the grandfather here. Okay, I can simply inherit my parent so that obviously it will come all the hierarchy, sorry, multi-level, right? I am always getting confused between multi-level and hierarchy. Okay, let me tell you the hierarchical. Hierarchical, let me explain. Hierarchy is like, let's say you have taken a class as an animal. Okay, so here what I have done, I have implemented the core functionality, just like our Celtos example, right? Let me tell you that Celtos example only. Let's say I have taken the engine. Okay, so this particular engine will go to your Celtos as well, right? As well as your Creta as well. Okay, if at all you want to discuss in our generic life, right? What you will do, let's say you have a parent, you have a brother and sister, right? So both will be inheriting this particular parent, right? That means by hierarchy, they have received, both receive your parent, right? It's not like a 50-50%, just like our law is little different. But here, both sister and brother will get the equal level of properties from your parent. Okay, this is called your hierarchy. You are maintaining the hierarchy not only for one, you can inherit that particular parent class into multiple classes. That is what the hierarchy is telling. It is not restricted to be inherited in one class. You can inherit the parent class for your multiple classes. That is what the hierarchy is telling. Multi-level. So multi-level is like, for parent, you have one more grandfather. Okay. From his you are getting this, and from here you are getting into brother. Right? There you are getting both. Here I am telling one is at the hierarchy, the what you call vertical level, other one is at a horizontal level. Okay. Let's say you have a brother. For brother, you are taking a parent and grandfather, right? You are taking this. But here in the horizontally, if it is a hierarchical, you are horizontally taking. Let's say here brother and sister. Brother and sister might also take grandfather and parent into your sister. If your parent is coming to brother and sister, let's say two ways, it is hierarchy. If it is from multiple levels, from your grandfather to parent, parent to your brother, this is called your multi-level. If you have multiple levels vertically, then it is multi-level. If it is horizontally, the parent is going to multiple child classes. Okay, then it is a hierarchy. Okay. Okay. Now, look at the way how the same function will work. Okay, if I create a same function name in both my parent classes, let's say I am doing a multi-level. Let me write that logic. Okay, in this case, not in this case, where is the one? Where I have inherited multiple. Yeah, let's use this. Let me change this to, let me copy this. Okay. Okay. I need not use the same also. I can in one class I can use this. I one class I can use me also. That is not a problem for me. Okay, because I can take any name. So now my problem is I have used the same function called use balance. Okay. Now I am inheriting both the parent into my child class, right? Now if I make a call of use balance, okay. Now if I call this particular account one equal to, right? So which use balance function will be called? Because I have inherited both savings and current, and I have inherited and I have written the same function in both my parent classes, right? Can you see this? Can anybody guess what function would it call? Anyone? Account only, but that, oh, sorry, just a minute. Okay, now let's see using balance from account. Okay, now I have defined in all the classes, right? One is savings, one is in the current, one is in the in this one also. Okay, so people are guessing it would call your account. Okay, let me rerun this. It is calling from the account, but I don't want to call the this one. Okay, let me remove this. Okay, now if I rerun, but this use balance is coming from your savings and current. First preference it has given for this particular class. That is directly understandable, right? Because you define the same class, same function in your child class, so it is taking child class one. Now I have removed that particular child class. Okay, now which function it will use? Whether it will use your Celtos, your savings or a current bank. Which parent? Because I have used two parents. Two parents have the same property. Okay, let's run. Okay, it is first giving the preference to the savings. Okay, because the first parent is your savings. Okay, if I change, okay, I rerun this and then it is calling the first parent. So here, if you have over ridden, okay, your parent class function in your child class, it will always call the child class. If at all your parents has two different functions, then it will call based on the order of your parent. Okay, clear? There are two distinctions. One is if I override that particular function in my child class, it will always call the child class only. First preference is its own method. But in the other way, if your parent class has and your two parents has the same function, then it will call based on the priority order, means the defined order. Okay, clear all of you? Raghu still stick to hybrid only. Yeah, Raghu. Okay, I'll explain you, Raghu. Where is the hybrid? Okay. Okay. So look at this particular Raghu. If you look at this particular class, okay, animal class I have taken, and then I have taken the class of mammal. Okay, where I am inheriting this particular animal to my mammal. Okay. And then here, if you look at this particular example, I have used what? I have used a inheritance in my mammal, right? Single inheritance. Now, what I'm trying to do here, I'm trying to use this particular mammal. That means what it is doing? It is doing a multi-level, right? From this one, let's say this is grandfather and parent. Parent you have inherited into child, right? Multi-level has happened. But apart from multi-level, I am trying to inherit one more class. Let's say the bird also is inheriting this particular animal, right? So this one also I can pull and use it here, right? That means I am using multi-level as well as multiple inheritance, right? That means I am using a hybrid, right? I am using hybrid here so that you can use both different higher inheritances in one more class. Okay, so you are using both multi-level as well as multiple because you are using two parent classes, right? And the parent class is inheriting from a different parent. So you are doing a multi-level and multiple in the same inheritance. Both are happening. Okay, Raghu. Okay. Now, if at all you have come to your child class, okay, in the child class, whenever your child has inherited your function, but you wanted to call your parent function only. Okay, let me repeat. Let me make this big. Okay, let's say I have defined, we'll come back to this init function. Okay, don't worry about at this point of time. Okay, you ignore this. For now, let's say I have defined this particular function as a display info. Okay, I have inherited this particular animal into my child class. Okay, I have inherited animal, right? Now I have defined my display in my child class. Okay, but in the child class, you want to call your parent class function, which is like this one. Okay, that time what you need to do, you need to, if at all you want to call your parent class function in your child class function, you can use a keyword called super. Okay, you can call a keyword called super so that it will call your parent class function from your child class function. Okay, because in this, if it is outside of this function, you can clearly say animal object dot this particular function, it will call your animal only. But in your child class, if at all you want to call your parent class function, how do you call? You are inheriting this particular class, but how do you call? You should have some way you should be able to call, right? You can't define an object of animal here because you are already inheriting your parent class. That is why they have given a keyword called super. Whenever you mention super, it will call the function of your parent class. Okay, let me write the code and show you. We are not only discussing the syntax, right? Why we have to do that is more important so that it will give you the clarity. Okay, let me write a one class. Let me say, okay, animal is not Ranbir Singh. It is simple animal. Okay, I'm writing definition. It is play. Okay, as this should be a instance method, I'll be using self. Okay, now print parent animal class function. Okay, I have written like this. Now I am inheriting into another class cat, which is kind of an animal. Okay, now I am using definition of display. Okay, now I have written this is a parent class. But somehow I wanted to execute the logic of my parent class in my child class, right? What generally, if at all you want to use this outside your classes. What you will do, if at all you want to call, you will simply create an animal object, a equal to animal, right? And then you can say a dot display, right? So whenever you call, it will call your parent class. But in your child class, you wanted to use an animal class function. Okay, how would I do? Okay, let's say some people may say that why don't you create an object animal and a dot display. Okay, I have done this one. Let me create an object of my child class c equal to cat and then c dot display. Okay, see, sorry. Mm, Okay, it is calling the parent class and then child class, right? So you are able to do this one by creating an object of your parent class. But do I need to create an object because I have a animal inherited already, right? I need not to create an object of it. Okay, simply I would say super dot display. Whenever if I run this, I would be able to achieve this one. I need not to create any object of your class. I simply say super dot display. That means it will automatically call your parent class object. Sorry, function. Okay. Okay. Ravindra is asking why I need to create a same class in my child class. Okay. For example, your father has started a business and you have inherited the business. Would you do the similar way? Because you are a more powerful and you wanted to completely revamp the business of your father, right? That time you try to implement your own functionality, right? Your own functions in the same business, right? Exactly similar to like that, right? Your parent has given you some function, but as a child, you wanted to tweak that particular function a little bit, right? So that you will implement your own way of running the business, right? But if at all you want to call, let's write that way also, right? With that example only, let's say I've taken a class of a parent business, the parent as our class definition as a run business. Okay, print this is run by parent. Okay, now child has come class. You have given means the parent has given the business to your child. Okay, but would you want just similar to your parent? Do you want to run the business? Not really. Let's say if I use this, I need not to use anything. I will say, let's say pass here. Means I don't want to create any logic at this point of time. But as my child has already inherited, okay, I would create an object of my child, c equal to child, okay, and then c dot run business, uh, run business, where is the run business? Attribute of run business. Okay, maybe it is referring previous child one. Okay. Hmm. Child one. What happened? Child object has no attribute of I inherited the parent. Mm, mm. Is it referring to above one, parent one, to one? Yeah, maybe the parent it was referring as above function because somewhere we have created a parent also, right? In the memory still it had that one. Okay. Now the child is running the parent class business only, right? But do the child always want the way how the parent is running? No, obviously, right? I wanted to run the business by myself, right? So then I will update the functionality. But I need to completely carry out the business by myself? I will actually enhance, right? So here I will use run my father business or my parent business, right? Mother business, and then on top of it, I add my some excellence, my excellence, right? So that part kind of a functionality I should be able to achieve. Okay, so I will run the business of parent. On top of it, I add my own thoughts to improve the business, like Ambani, right? Ambani has created his own kingdom. Now Mukesh Ambani is adding his own flavor of enhancing the business, right? So that is why you will be writing the same function to enhance that one. But if at all, rather write starting from the scratch, you will take the property of your father and then you will enhance on top of it. Okay, Ravindra? This is why we are inheriting and then enhancing the inherited function also. Okay. Rather than creating an object of your parent class, because you already have a parent reference, why to create a parent class object, right? So that is why we just need to call a super so that it will call your parent class functions. You can call your parent class functions in your child class without creating an object. You need not create any object. Okay. So this is a keyword called self. Okay. Self is used to do what? To do call your parent class function or a base class function in your child class. You want to call those functions. Outside the class, you can simply create an object and you can use it, right? There is no problem. But in the child class, what all you want to use, rather than creating an object, you simply use the super keyword to call your parent class functions. Okay. Now, there is one more core concept which will be very, very, very important is a constructor. Okay. Where is my, yeah. Next concept is called constructor. What is this particular constructor is do? Let me write. Let's, let's take any example of, okay, IPL. Let's take, this is a hot topic, right? So let's say IPL, I am writing a class here. I wanted to, okay, why to make it complex? Let me say one player only. Okay. So I don't know whether your favorite cricketer, but my son's favorite cricketer is Kohli. So he'll die for him. I don't know what he has done for him, but because of him, though he is belongs to Hyderabad, he is a favorite of Bangalore. He is fan of RCB only. He will always curse SRH, though he is from Hyderabad. But anyway, that is a different story, right? Let's say now what I want to do, I want to take this particular object. So I have created this particular class called IPL. In the IPL, I want to there. Okay, I have this particular Okay. Now, if I am creating an object, okay, I'm creating an object of IPL. Okay. Match equal to IPL. So I did earlier I was creating like this, right? The object I am creating this one. Whenever if I run this, okay. So IPL is okay. First I need to run this class. I have defined this particular class. I have run this one. See, whenever I am creating this particular function, sorry, my object of my class, it is telling that missing two required positional parameters. Why? I have defined this particular function, but I am not calling this particular right? I'm just creating an object, but the object creation itself will inherently call this particular function, which is called constructor function, okay, or constructor simply, okay. What this constructor is, that constructor is, you need not to write it as a constructor, you need to name this as underscore underscore init underscore underscore, okay. You need to define the name as exactly like this. You cannot change the name. Okay, it should be underscore underscore init underscore underscore. Why I need to call? Because certain things I want to initialize for my class when I am creating an object itself, right? That time I need to create a constructor in my class. Okay, remember this. They will ask what is a constructor? Why I need to use a constructor? Without writing constructor, can't I do it? Okay, because you can rewrite this one by using a function also. Okay, you take a function, in the function you assign a name, you pass the name and ID to your function, and then you will assign that particular values to your instance level properties. But that time you need to specifically call a function, right? But here, while creating the object itself, I would be able to set those properties while calling the object itself. Now I need to simply say match one, and then the ID is something, let's say 123 is the match ID. Okay. Now if I run, I would be able to create this particular match. Okay. So now whether this particular player is playing in this particular match or not, let's say match. Okay, name I have given match name, not match name. I need to give a player name, right? Let's say okay. Now if you look at this, match dot no player, Kohli is in the game. Okay, so this is how I could be initializing this particular whatever values. And as this is internally mapped to your object creation, obviously the first parameter should be your self. Okay, obviously you will be passing, but you need not to pass, right? As you are using this particular class, when you are calling a function of your class by using an object, obviously the object is passed as a first parameter that we discussed earlier. Now even in the constructor, as this is related to the instance of that particular function, the class, right? Automatically your constructor will receive the object of that particular class. That is why your constructor must have a self as a first parameter, and then the name must be underscore underscore init underscore underscore. Okay, there is no alternative for you. You can't change this. Like self, I can write it as this or whatever name I want. Okay, but here you must define this as init only. Okay, and you need to mention underscore underscore. Okay, this is called the constructor, where this will be automatically get called when you are creating an object. I need not to call IPL dot init. I need not to call this function. It will get automatically called. Okay. So now if at all I want to use this particular parameter, I can use, let's say now I will be using this particular name in my function. So before calling any function, if at all you want to initialize any parameters, you would be using this particular constructor. Okay, for example, you have a vehicle. Okay, so I tell you start the vehicle. Do I need to tell you need to pour petrol or diesel to your tank? It is a default, right? That should be part of your constructor. You should keep that one, right? But to initialize those things while creating an object itself, right? That all the predefined things you will keep into your constructor. Okay, understood the constructor one? After init, shall I create a custom name? What is meant by that, Ravindra? I didn't get your question. After init means this is a one function only you need to write. Your this is the only remaining all your own custom functions. You need not to follow any rule, but for only for this you need to follow some rule constructor. And there are some other functions I'll explain you. But at this point of time, constructor name must be this only. You can't change the constructor name because you are not calling the function, right? You whenever you are creating a class, it should know default what function to be called. That is why your Python told, okay, you define it as underscore underscore init underscore underscore so that I will call when you are creating an object. That is what Python has created internally. Okay, let's hold at this point of time. Tomorrow we will discuss there are the different functional like dunder methods, right? And there are certain other concepts like a polymorphism, right? We'll try to discuss certain details about polymorphism, and we try to use some other functionalities like how to control your data inside your class and all of that. Then mostly these are the things you would need at the OOPS level. Okay, class, how to create an object, how you can inherit, right? And what is a super keyword, what is your constructor. If you know these things, and then whatever topics we discuss tomorrow, that is more than enough for our generative AI and agentic AI functionality. Okay. Do we have different types of a constructor? You can have different type of a constructor. Means why do you need different type of a constructor? Means you are telling if at all I want to pass different parameters. Is that your question? There is no different type of constructor. It is a same constructor. Just if at all you want to change, you simply pass some parameter. Let's say name you wanted to pass always like a player. Kohli is a default player. Okay, you can pass like this. Okay. 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 No, you can pass like this the parameters. Then you need not to pass so that you if at all you wanted to run like this. Sorry, I need to run this first. And then I will run. Okay, it has created. Now if even if you run, this is taking as a Kohli as a name because I have given as a default player. Now if at all you want to change the player from Kohli to some other guy whom you need, Rohit, huh? All are old guys only. You want Gen Z guys. Who is a good player now in IPL? Abhishek, huh? Let's put Abhishek. Okay, now if I pass, where is yeah, Abhishek is the player. Okay, now I can pass. So this will same constructor. I can make this as a default constructor, which if you don't pass, it will take Kohli. If you pass, it will take whatever name you pass. Right? Rakesh telling we don't have to define name and ID as a class variable before using them in constructor, not required in Python. You don't need. You don't need any define. So in other programming languages, it will restrict you to create a name and then ID, right? Here in Python, it will not restrict. It will automatically dynamically take these parameters in your class, okay, which are not class variables. These are variables at a object level, right? That's why I'm taking this particular self. If I create a new object And for the new object, let's say here I have created, this is a match 1. Okay. Now I create a match 2. This is a new object. For that, I will call like this. Okay. There, my default player is Kohli only. Right? Let's say if I want to call match 2. Okay. So like this, I have, right? So at an object level, it is getting stored. That means two instances of these are stored. Let's say you have created two objects, right? One object is match 1, other object is match 2. Each will have, this object also has a name, this object also has an ID, this object also has a name, this object also has a ID. Okay. So these will not overlap. Okay. That is why we are creating with the self, so that these will be shared only within the object. If at all you want to have a common, then you will create an object, create a name at a class level. Those you need to define. Okay, let's say you need to say stadium, which is Uppal Stadium. Uppal Stadium, what is Rajiv Gandhi Stadium? What is the Uppal Stadium called? I don't know. Huh? My son is, see, Rajiv Gandhi. Okay, so stadium is common across my matches. Only my players would change, right? So even if I call, I can't call with the, right? I will say IPL dot stadium. Okay, if I want to print, I can print. Okay, that is how I would be defining at my class level. If at all I wanted to share among all the objects, I would be keeping at the class level. Okay, if at all I wanted those parameters to be at the object level, I would directly say self dot name. It will be managed at the object level. Okay, in application level means class level, you are telling, Ravindra. If you are meaning by class level, the yes, all the inherited classes will get this particular value. Okay, if you meant by application means class level, yes. Constructor init should be defined at the top of the class only. Maybe it is not that requirement logically. Let's see, because you are giving a specific function name, right? Let me, okay. Okay. Whenever I call this match 1 and match 2, see, it is still working, because if this is order, then it must, they might have given a flexibility of creating by our own name, right? But if they are telling that this function to be created in this name only, that means you can create at any place of your class. Okay. Okay. Ravindra, maybe I'll give you access to Mike. Ravindra, you can ask the question. Okay, let me see. I can find you or not. Ravindra, Ravindra Babu Lanke. I've given you access, Ravindra. You can ask your query. Okay. Muniram is asking what is the difference
Yeah.
between
Hello,
constructor.
sir.
Yeah.
Is it audible?
Yes, you are.
Yeah. So yeah, my doubt was so what is my question? Application in the sense, like, take it as any application. Like, of course, you explain like banking is one application. You clearly tell that. But for example, if you take it as a generally regular, Amazon application,
Mhm,
from my question, from the whoops, right?
mhm,
We don't want to use for all the whatever we have in scope of use. We are not use. I think we certain concept we are using. That's the point number one. The second point is in the inheritance rate. You explain like there are I think four plus five categories of inheritance types you explain.
mhm.
So what make uh, use frequently? That's my question. So that then I
Okay,
will explore more that.
okay. Second question I understood. Which inheritance type is mostly used? That is second question. First question, sorry, I didn't get the first question. So to answer your first question, so it is not that which type of inheritance you would use, right? It is dependent upon the use case.
Yeah, yeah,
You might
yeah.
need to use any type of inheritance. Don't think that this is what I would use, right? So these
Mhm,
are the different functionalities given by Python
mhm.
based on your requirement. Let's say you want to use your parent class, but your parent class are two, three parent classes you have, okay, which you need to use. For example, in one example in the banking, right? What I told, I in my account, I need to use both savings and current as my account, right? In that case, I will be using a multiple inheritance, right? So in other case, I need to use in my car engine use case, engine, and
Yeah,
then you have a Celtos and then the other cars, right? That means one single parent is getting used in multiple child classes. There you will use a different inheritance. It is depends on what is the use case, right?
okay.
You need not to fix it to this inheritance only I would be using. It depends upon your use case. Okay, what is the first question? Sorry, I missed your first question. I didn't get that question.
Yeah, generally for the see how we are using like application mostly most commonly see without doing from the first example you're telling like if we have integrated other tools
Mhm.
most frequently in a popular we are using like same thing. So what is my question in whoops? So we have different types. Most frequently what we are using concept.
Most frequently we use a simple inheritance.
Sorry.
Okay. Simple inheritance. One
Simple
parent
English.
class, you will inherit in the child class, right?
Okay, great,
But in
great.
the complex use cases, you might need to use different inheritances. Generally, we use a lot of single inheritance.
Okay,
That
great.
is generic use case.
Hmm.
Okay. Muniram is asking what is the difference between constructor and this init py. Okay. So don't get confused between those two. So they have. I'm so sorry. So here the underscore init. This is the function what you are creating to tell your class that when you are creating an object of that class, you try to run this particular function. That is what you are telling. The other is when you are creating a folder, right? You are instructing your Python to understand this as a Python. You are creating a file there with the same name called underscore init underscore. That's all. Okay. This is at the class level where you are telling what is the default function to be called when you when you create a object, right? But there you are telling whether to define your package or a folder as a package. You are defining a file. That is the difference. That is a file. This is simple function in a constructor. Maybe the name may confuse you, but the same name they are using within the class as a default function to be called when object created. In a package level, they are using the same name, but that is a file name you will be giving to make or to indicate that folder as a package. Okay, Muniram? Okay. Does anybody have any questions? Okay, seems like you are good. Okay, let's continue tomorrow on the other topics of inheritance. And more or less, we have come to certain logical end to the Python, right? Maybe two, three concepts. We have iterator and generative object, and then few things like exception handling and all. We will mostly cover tomorrow if time permits, or else mostly cover day after tomorrow, and then we get started with creating our own chatbots. Okay, quickly we will discuss the creation of chatbots. Okay, Ramesh Vesta has you have a question. Let me search for your name. Ramesh. I have given you access, Ramesh.
Hi, sir. Thank you. Hope you're able to hear me, right?
Yes.
Okay. So actually, in a multi-level, sorry. So in a one kind of inheritance, right? For example, we have a two parents, and I created a one child. Um, so in the child, actually, you said that how we can call the child function, and how we can call the parent function, but using the super keyword. But if I have a two parents, you said that the by default it will call the first parent, right? But if I want to call the second parent specifically, how we can call? Is there any way?
I don't think you can call specifically the parent. Let me see. Your
No. Hope you got my question.
Yeah, I got your question. Just give me a moment. I'll go to that particular account only, right? That is a use account. Yeah, this is use balance.
Yeah, saving
You go
and
to this is the one, right? So you are telling rather than calling a savings, I want to call the current.
yeah, right.
Sorry, I think there is no specific logic to call a second one. I think you need to change this order so that it will call. Or let me see if there is any functionality like that. But this is a good question. Let me see.
So if you are calling directly, it will come the child class. If you are using the super, it will call the first parent. But yeah, if I'm going to call,
Okay, it is telling you can directly call like this. Let's
okay.
say if at all you want to call, let's say in the check balance, okay, here you say savings dot use balance. Okay, so this is what it is telling. Let's see. I don't know whether it is will work or not. Let me account dot check balance, right? Account one dot check balance. Mm, use balance. Yes, check balance has. I need to call check balance here. Yeah, it is telling you can call this way. Okay, by using a class name itself, you are able to call that particular function, whichever parent function you want to call, you can call by using that particular parent. Maybe in the object, right? If I directly use, okay, let's say if I use directly the use balance, use balance. Let me remove this. So this is what one more question, right? One is you can put it in the your function. Other one is let's say as it defaultly inherited your function, it is still calling the current. I think there you need to specifically call your parent class only. By using a parent class object only you can call. There is no other way to call at this point of time, or you need to separate between your parents. Okay, somebody is asking another question. Okay, in this way, you don't have any other option. It will call only the order. Actually, there is a functionality called, I'll show you that. MRO, we call it as method resolution order. It will tell you with which order it will tell you. So, dot MRO. Sorry, not capital. Small MRO. Okay, so it will tell you the order of what it will call. Okay, first it will look at the account, and then it will look at the current, and then it will look at the savings, and then it will look at the credit card. Okay, like this it is telling, and then the object. This is the order what it has defined already. Based on that order only it will do. If at all you wanted to separate it out, then you need to make use balance underscore savings, not to confuse, and then you can use balance underscore current, so that you can call the specific function of your parent. That is the only way. Okay, Ramesh. Okay, so one is you can within the class you can call by using a class name that we have seen, right? But outside the class, if at all you want to call, it is defined by based on the MRO only. MRO means method resolution order. In some interview they have asked this question: what is it? Do you know how Python call the methods in which sequence? How do you know, right? So you can say that python.mro will give me the method sequence which is defined by my Python, so that I will know what is the sequence of methods it will call. Okay, MRO is the answer for that. Okay, okay. So let me see if there are any. Okay, Ayushi has raised her hand, his hand. Let me see. Ayush. Yeah, Ayush, I have given you access.
Yeah, happy good morning.
Hey, good morning.
So, Prithvi, as you mentioned, that okay, in next 1 or 2 days we'll complete this Python groups concept and all.
Right.
So, don't we need to learn this fast APIs as well to for this our GenAI applications?
That will cover. That I am not considering as a Python. The core concepts only I am considering as a Python. Okay,
Okay,
fast API, the API consideration obviously we need to cover. That we will cover. Okay,
oh, so fast
core Python
API.
only.
Okay, so fast APIs we are gonna learn in the Python itself, right?
Yeah, so I'm not considering that as a Python. I will be considering as a library which needs to be used for your API calling. So that will be separately taught.
Okay, cool. Thanks. Thank you.
Okay. Thank you all. Let's catch up tomorrow. Okay. Bye all of you.